Okay, fifth graders, today is Thursday, the day before our weekly check-in tomorrow, and we are going to be doing lesson 11 from module 3. Okay, and today what we're doing is we're going to continue working on making equivalent fractions, but instead of just adding them, we're going to also see how we can subtract them. Subtracting is similar to adding in that we have to make like units, okay? But it's different also because is there a commutative property of subtraction? Is 1 minus 2 the same thing as 2 minus 1? No, right? Right? What's 2 minus 1? 1. Let me commute it. What's 1 minus 2? Are those the same thing? No. So we cannot move around the whole number parts and the fraction parts to make it easier for ourselves. That's the tricky part, okay? But first, let's talk about the problem of the day. So this was a simple example to show you how the rectangular fraction models is the same as when we use multiplication, okay? This is very similar to what we did when we were making equivalent fractions to add, yes? It gets a little trickier when we start to deal with mixed numbers. Do you guys remember how when we had mixed numbers for addition, we would add all the whole numbers first and then we add all the fractions? Does that work for subtraction? Unfortunately not. Okay, so we're going to take a deeper look at how we can handle it when we have mixed numbers. So here we have a mixed number and we're going to subtract a fraction. There are actually two ways we could do it. Okay, we're going to first explore what happens if we just keep the whole number a whole number. Let's just look at the fractions for a second. We have 3/4 and we have 3/5. Ignore the whole number for now. Don't forget it forever. You'll make a mistake if you do, right? But let's just look at the fractions first. Do they have common units? No. So we're going to have to find the least common denominator in order to multiply and make equivalent fractions. Let's skip count by 4s, and then we'll stop when we get to 4 times 5. Okay, 4. Is that good? 8? 12? 16? So we have to do 20. Okay? So let's convert. We have 1 and 3/4. I can multiply that by some version of 1 to get 1 and some number of 20ths. Right? What version of 1 should we multiply by? 5/5. Okay, now, technically we have to do 1 times 5/5. What's 1 times 5/5? 1, right? And then we do 3/4 times 5/5. What's 3/4 times 5/5?
15.
Okay, so don't forget, we're really multiplying the whole numbers too, but 1 times 1 is just 1. Okay, then we have 3/5. I can also multiply 3/5 by some version of 1 to get a number of 20ths. What version of 1 should we multiply by this time? 4 over 4. So 3/5 is equivalent to? Okay, so this time, now we can rewrite the problem. We have 1 and 15 20ths, and we want to take away 12 20ths. Does it work if I just keep the 1 separate, and then I can say 15 minus 12 is 3 20ths? Does that work? Yeah. It does, because our first fraction, 15 20ths, was bigger than our second one. What would it have been if the problem was a little bit different? What if it turned out to be like 1 and 10 20ths minus 12 20ths? Then can we keep the whole number separate? What would we have to do to this 1? We'd have to regroup it. We'd have to think of it as 20 20ths, right? We'd have to say this is the same as 20 20ths plus 10 20ths minus 12, right? So it'd be 30 minus 20. Does that make sense? But if it's like our original problem, then we don't have to regroup, okay? So we can, again, look at just the fraction parts, 3/4 and 1/6. And we can see if it works out where the first fraction is bigger than the second fraction, then we're good to go, right? Because then we can just subtract the whole numbers, because in this case, the first whole number is bigger than the second one, right? And we don't have to regroup. But if it's too small, then we have to regroup. It's just the same as when we're regrouping for anything else, okay? So do we have like units?
No.
We have 4ths and 6ths. So let's skip count by 4. You could also list them all out, but I just like to do this because it's, I don't know, to me it's faster. Okay, so we think to ourselves, is it divisible by 6 since we're skip counting by 4? When do we know we can stop, by the way? Which number?
24.
Okay, good. 4.
No.
Okay. 8.
No.
What's next?
12.
12.
Yeah.
Oh, yay. So then our least common denominator is 12. Okay, so let's multiply to make equivalent fractions. 5 and 3/4 can be multiplied by some version of 1 to be 5 and some number of twelfths, right? What version should we multiply by? 3 over 3, good. Which tells us that 5 and 3/4 is equivalent to 5 and? Okay, good. Now let's do 3 and 1/6. We can multiply that by some version of 1 to get 3 and some version of twelfths. And some number of twelfths. What version of 1 should we multiply by this time?
2 over 2.
Okay, good. So 3 and 1/6 is equivalent to 3 and?
2/12.
So how could I rewrite my problem so that I have like units? How would I rewrite my problem in a way that has like units? Ikash.
5 and 9/12 minus 3 and 2/12.
Okay. Now before we subtract, what do you notice about this? Is 5, the first whole number, greater than the second whole number? Yeah. Okay, that's pretty nice for us. And then what about 9/12 minus 2/12? So in these examples today, we don't really need to regroup. If we needed to regroup, could we? Sure. Okay, good. So what's 5 minus 3?
2.
What's 9/12 minus 2/12? Ask yourself before you box the whole answer. Is 7 and 12 in its simplest form? Yes. So our answer is 2 and 7/12.